Namaste and welcome. Today we are going to estimate the land surface temperature LST in ArcGIS. So first of all we need to open the ArcGIS and we have to download the Landsat 8 image. Most probably the month ranges from October to November for better clarity. So I have downloaded here Landsat 8 image. So I need to extract it. Yeah, it's going on, and then we need to add the data from extracted file, which I have kept here. Yeah, it's here. So we need to first of all, first step is to convert from DN to top of atmosphere TOA radiance using the radiance rescaling factor, and the thermal infrared digital numbers can be converted to top of atmosphere TOA spectral radiance. So we need to add first of all band 10. Here it is. It's headed here. So we need to search raster calculator from here. Raster calculator. Now to apply the formula, what will be the formula, or we need to change it in short form, so it will be easier while calculating to insert the formula. So rename it just as a B10, which means band 10, and here you can see that here is the formula which is used to convert the digital number DN to TOA radiance. The formula is L lambda is equal to ML into QCL plus AL minus OI, where L lambda means TOA radiance and ML means multiplicative factor and AL means additive factor and QCL means DN value, OI means correction factor. So how to find out the ML values and AL values? For ML values and AL values, we can find out here. Here you can find out the text where you can find out the average mean for band 10. For band 10, we need, you can see there. Yeah, it's for band 10 radiance. We need to go through band 10 radiance. So you can watch here MTL text. Yeah, here it is. Radiance for radiance maximum. Here you can go reflect radiance 10 for band 10. Radiance at band 10 means value 0.100, and for reflectance, yeah, for radiance maximum, for radiance maximum value we have got from there, and for yeah, you can see here. I'll provide this data in the comment box, so it will be easier to locate. So from raster calculator, you can find that formula of the value of ML means, which means 0.0034. So we can directly type here 0.00342 slash divide by it's multiplications into band 10 flush, and the AL value means, so it means 0.100 minus 0 correction factor, which means 0.29. Yeah, now for output we need to careful here. So we need to keep the respective output in concern folder for further use. So I have kept here. Yeah, I need to create a new folder for output, and I can rename it as a TOA for better understanding. Yeah, so it's the formula. You can see there it's 0.0. I have kept that lambda, which means TOA radiance. So I have inserted this formula for calculations, and it will be okay. So it's executing the raster calculator. And for second step, we need to convert the brightness temperature. For brightness temperature, we need to for there is formula BT is equal to K2 divided by ln bracket K1 divided by L lambda, which means we have already renamed it as a TOA, and plus 1, and for conversion of degrees that temperature in degrees Celsius minus 273.15. So we'll be following the second step. For second step, again we have to go through the raster calculator, and can write there formula for step 2. Yeah, for we need to keep this formula there. So you can slightly copy, or you can just manually type here. So it will be better for you type here to make it error free. 0.78 and divided by ln. We need to keep ln from here. So it's a bracket ln 774.8853. Again, it will be divided by TOS. So we need to keep this in this one, and plus 1, and we have to keep it double bracket, and minus 273.15, and we need to keep the output. Now for renaming, we need to keep it as a BT. Yeah, it will be BT. So it's called, you can what's there. Yeah, it's this one formula where K1 and K2 are the thermal constant. For thermal constant, there are the values. You can say it here. For K1 and K2, there is a value. For K1, 774.8853, and for K2, there is the value 1321.0789. So you can give the command OK. It is executing the raster. Now for third step, we need to calculate the NDVI. For NDVI calculation, we need to add data of B1, B4 and B5. So again we have to add data from here, B4 and B5. Now first of all, for making the calculation easier, we need to rename it in shorter form, so it will be easier to calculate while applying formula. So just go through the property and rename it. It is yeah. I have kept here. Now again go through the raster calculator. As previous video I have uploaded how to calculate the NDVI in this YouTube channel. You can also watch there, or or simply follow the step. Yeah, plot for NDVI formula. For NDVI, we need to insert values for NDVI to calculate NDVI. Band 5 minus band 4 by band 5 plus band 4. So band 5 minus band 4 and keep here divide by, and again keep here float and band 4 plus band 5. Yeah. You can watch here formula. Yeah, it's formula. Yeah, here you can watch this band 5 minus band 4 divided by band 5 plus band 4. So we need to put the output raster name as a NDVI. Yeah, it's okay. So we have calculated NDVI as well. Now we need to calculate the step 4, which is land surface emissivity, LSE. For LSE we have to follow the formula. Here is PV. We can name as the output as a PV, and there is the formula in bracket NDVI minus NDVI minimum divided by bracket NDVI maximum minus NDVI minimum. So we have also got here the NDVI value. Now again we have to go through the raster calculator, and for formula we need to there square and square and bracket, and the NDVI means you can insert this NDVI minus. Now you can have value NDVI minimum. NDVI minimum means minus 0.3219. So minus into minus multiplication means we have to keep it as a plus. So 0.32193, and according to formula I have to keep it, and it's divided by, and again I have to insert the bracket NDVI maximum. NDVI maximum is 0.621389. Yeah, and again NDVI minus NDVI minimum. So minus into minus means plus. So plus, keep this value here. Just 0.32193. Yeah. Now for output you can name as a PV. Yeah, we have kept this formula as simply it is shown here for step 4. We have kept this formula. PV is equal to NDVI minus NDVI minimum, and NDVI maximum minus NDVI minimum. So I have kept this formula. Now we need to execute the raster. So it's calculating. Yeah, we have also calculated the PV values. Now we need to calculate the for emissivity. For emissivity we need to calculate the value E. For emissivity you can watch this here. For emissivity formula, E is equal to 0.04 into PV plus 0.986. For E means land surface emissivity and PV means proportions of vegetations. To calculate E, we need to go through here 0.004 into PV means we have to insert this PV and plus 0.986. We can put the output name as a E. It will be easier to understand. Now for fifth step means the last step for LST, which means land surface temperature. Land surface temperature is calculated using brightness, temperature, and emissivity. For formula, we have to follow this BT divided by 1 plus lambda into BT slash P value into LNE. So we need to again go through the raster calculator. Yeah, here it is. Now for formula, we need to insert BT divided by bracket 1 plus bracket and lambda value is 10.8 into BT again divided by 14388 and close the bracket into ln log n e. Yeah, now we can put output as a LST. So we need to put here as a double bracket. It's showing error. Yeah, now it's fine. So we are following this formula where this lambda means wavelength, P value where we have kept that 14388 and BT value we have calculated from step 1, and for P value which means P value which is land surface emissivity which is calculated from step 4, and for E value which is calculated emissivity. So it's fine. Now we can execute the raster. Yeah, it's almost done. So now we need to extract the area of interest from these tiles. So I'm going to extract Sarlahi district from this one. Yeah, for LST value we need to put here the Sarlahi district. For Sarlahi district I have already extracted the study area. Yeah, to extract I had kept here. Yeah, Sarlahi district. Yeah, it's here. So we need to extract by max because we are going to extract from raster file. So from source menu you can go by searching extract by max. So it's here. Just put input raster in the LST and input raster or feature max data as a Sarlahi, and we can name as a output as a Sarlahi LST. Yeah, it's okay. So we have calculated the value of Sarlahi district. Now we can change their color from properties. Just go through the symbology and through the classified values, and you can check from low to high. Low temperature means 13 degree, or you can just put apply color on the basis, and you can also just limit this label. We will just put it label. Format, you can go through the format level. So just put 2 digit, it will be better. Yeah, apply, Yeah, it's showing the ranges from 14 degrees Celsius to 16 degrees Celsius in this area, and 17 to 17, 18. Yeah, we can classify according to our need. So I have can classified here as a 5 class, so I can classify it as a 2 class or 3 class. That will be upon your need. Yeah. So 14 to 17 degree, 19 to 20, 21 to 26 degrees Celsius. So in this region there is 21 to 26 degrees Celsius. In this region you can find that 19 to 20 degrees Celsius only. In this region it's about 14 to 17 degree. So how can we relate that those area have a low temperature? Because the area showing with the green color has mostly the forest cover. You can also watch by putting those say file in Google Earth, or either adding base map in ArcGIS. So let's compare it. So I am going to add the base map here. It will be easier to understand. Yeah, I have for adding the base map in GIS, your GIS must be connected to the internet. You can check it from here, notification bar. Yeah, it's currently connected to GIS. So look at it here. In the green part showing, we can relate it here. Is the green part showing means this area has a low temperature which ranges from 14 degrees to 70 degrees, because this area contain forest vegetations. uh, thank you for watching. It will be we are also going to show further analysis. If you need, please drop down uh, your comment, so we can improve further for your learning purposes, as well as for your research purposes. Thank you for watching and happy learning.